In this chapter, we're going to look at many applications of what we talked about with both the diffraction, dispersion, refraction, reflection, and how we can use these to make instruments. The first instrument we're going to talk about is a camera. It has generally a single lens photographic camera is an optical instrument. Real cameras have many lenses in order to avoid chromatic and spherical aberration. But in this class, we're just going to treat it as a single lens. The other interesting part about a camera is it has this aperture and it produces a real image on film. Here is a single lens SLR camera, single lens reflex. We have a single lens and the reflex is this mirror moves out of the way. We have this mirror in place so that we can look through the viewfinder to be able to see through the actual lens that's taking the image. The film or the sensor is back here on the camera. This mirror would then move out of the way to take the actual picture. So a digital camera would have a sensor on the back of it instead of film. The either film or a sensor is limited on the amount of resolution it has. Everything is pixels. In fact, our eyeball has pixels in it based on the number of cells that are on the back of the retina. So how does the camera work is we need to properly focus the image, and the lens to film distance will depend on the object distance and the focal length of the lens. That we're looking at 1 over f is equal to 1 over p plus 1 over q. So physically how far the film is from the lens, what the focal length of the lens is, will tell us what distances we can view. So you can buy a lens with many, many different focal lengths. A very, very high focal length with 600 millimeters will be basically a telephoto lens. Will bring a very, very far object very, very close. However, 1.4 millimeter or 14 millimeter and 20 millimeter are more wide angle, so you can see much more. And then the shutter is shown right here. Is a mechanical vise that is opened for a time interval in order to expose the film. If you get too much light in, you get an image that's overexposed. If you let too little light in, you get an image that's underexposed. The multiple lenses in an actual camera are to avoid phenomena of spherical and chromatic aberration. Here we can see some chromatic aberration, that we see a little greenish color right here. And here you kind of see some purple in this part of the image and green up here. So those are dependent on how far away the light is and how the light is bending through the camera. So with a small diameter aperture, only light from the center part of the film reaches the sensor or the film, and thus we can minimize this chromatic aberration. So the camera intensity, so we talked a little bit about this. So this is underexposed and this is overexposed. We want kind of in the sweet spot here. We have two basic little dials that can control that for us. Basically, underexposed means we don't have enough energy hitting the sensor or the film, and overexposed means we have too much light. So one dial that we have is the aperture opening. So the light intensity, and that's that I remember is equal to power over area, is controlled by the aperture. So if I change the aperture, if I change the area, then we let a different intensity light through and a different amount of power. So the aperture is given an F number. F number is defined as the focal length divided by the diameter. So the F number is one defined on the camera. So here, the larger the F number, the smaller the aperture, because again, we're dividing by the diameter. So a lens with a low F number is called a fast lens, meaning that it is wide open and has a very big aperture, meaning that it can let through a lot of light so that you can have a shorter shutter speed. So that's what they call it, a fast lens. So the F numbers are increasing the setting from one F number to another F number. The next higher value decreases the area of the aperture by a factor of 2, so it's half as much. The lowest f number setting on a camera corresponds to wide open. So the biggest number corresponds to wide open. Simple cameras usually have a fixed focal length and a fixed aperture size, and that's just going to change the shutter speed. And typically they're about 11. Most cameras with variable f numbers will adjust these automatically, or at least there'll be an automatic setting. You typically have to go to an SLR type camera before you can set your aperture manually. So one reason why you would want to control your aperture is this controls your depth of field. So the larger apertures have a narrower depth of field. So if I have my camera wide open, only this amount of distance is going to be in focus. Whereas if I have a small aperture, I'm going to have more in focus. That's because less light gets through. And the only light that is going to come through from these two disparate sources are going to be in a very, very narrow range. So here you see that we have here a very small aperture. We have a lot of stuff in focus. Here we have a very large aperture. And the only thing is in focus is in your flower. So if you have a fairly automatic camera, the landscape and sport modes will have a wide open aperture, whereas your portrait and macro will have a larger aperture to have a shallower depth of field. You'll typically find these indications on a dial on a camera. And on your smartphone, you also have portrait mode and landscape mode, and there's different modes depending on the camera app on your phone. The shutter speed is the other dial that we have. So we need to have a shutter speed that matches our aperture to be able to control the image. If I leave my shutter open for a very long time and there's any motion, we get a lot of blurring because this object has moved by the time the shutter is closed. Whereas if it's moving at the same speed, I'm taking a very quick picture, we almost like stop the motion. So a lot of the sports photography is going to be at this very, very high shutter speed in order to not blur. Or sometimes they do want to blur it, in which case they would increase the amount of time the shutter is open. And so that's how you get these cool streaking effects, is with the shutter being open a longer amount of time to get the streaking. So it's a balancing act. You have basically your shutter speed to play with, your f-stop, your f number to play with, and we want to get the perfect image. It's all about letting the perfect amount of light to that sensor or the film in order to get the perfect image. And what the perfect image means depends on what you're trying to do. Again, you can have a large aperture for a very narrow depth of field. You can have a small aperture for very wide depth of field, and then pick a shutter speed to match. Or if you know there's going to be motion, you might want a quick shutter speed and then a more wide open aperture, but that'll give you a narrow depth of field. So as a photographer, you need to make these choices. Next, we're going to look at the mathematics and how to calculate things like the focal length, the f-stop, and your shutter speed.